Hello everyone, it's me, Professor Aaron Albert, here again with lesson 26. Let's learn some economics. So today we're going to talk about price discrimination. We're going to solve for the optimal pricing strategy given second degree price discrimination. And we'll talk about third degree price discrimination. We're going to leave that one as a stone unturned. Alright, so the price discrimination that we're going to talk about today is group price discrimination. Suppose there's two types of consumers with different demand schedules. Our question is, well, what is the optimization problem then, right? You're a producer. You observe there's two different demand schedules. One, what is the optimization problem you're trying to determine if you can set two different prices to two different groups? And two, what is the profit function if you have two demand schedules and two prices? Give it a think. Jot down the math you think we're going to do. Let's see what it looks like. All right, so let's suppose that we have a firm. Their profit is given by their revenue from group 1, their revenue from group 2, as well as their total cost. It costs the same to provide to both groups. You'll notice that the revenue for group 1 is a function of how much you sell to group 1, i.e. Q1. Your revenue to group 2 is given by how many you sell to group 2. And again, your cost is just the total amount you produce, your C of total Q. If this is the case, what are our first order conditions? Well, hopefully you'll note that dQ1 is just going to be marginal revenue with respect to good 1. And this is going to be the marginal cost associated with group 1. And this will be 0. Moving on to the second FOC, for the second variable, you'll note that MR2 equals MC2. So really, although this seems obvious now, it's a little profound. If you're trying to group price discriminate, all you need to do is charge such that your marginal revenue equals marginal cost in both markets. So let's look at what's going on graphically. Here we have two markets. Because our textbook is incredibly dated, they love talking about DVDs, even though I've never bought a DVD in the last 5 years. And you'll note that the United States and the United Kingdom have two separate markets for DVDs. And my question is, which group pays more and why intuitively? Think about which group has a higher responsiveness to price and what you would do as the firm. Well, you'll note that a change in price in the United States will cause a fairly large change in quantity demanded because this demand schedule is fairly flat, therefore it is typified by high elasticity. The United Kingdom, on the other hand, is fairly inelastic. You can move price a good amount and have no effect on the quantity demanded. Therefore, we should expect this to have a high price since they are inelastic in the United Kingdom, and the United States to have a low price because they are fairly elastic and gouging them will lose you money. So let's check. Again, last slide we said set MR equal MC equal MR. So let's try it. We're going to set the marginal cost equal the marginal revenue of the United States. That says we should make 5.8 units. Tracing that up to the demand schedule like we do with the monopolists, it says we should charge 29 bucks. In the United Kingdom, same cost schedule. We'll set marginal cost equal marginal price, sell 2 million DVDs. Trace it up to price, and you'll note that we set the price to be 39, which is higher. So, therefore, firms should set the prices higher in inelastic areas and lower in elastic areas. And if they do this, they will make more money than if they had just optimized adding these two demand schedules together. To see that final point, we could do this thoroughly. So let's break this down in a separate problem. Here we have country 1, which is demanding books per day. They are fairly elastic. We have country 2, fairly inelastic with demand for good books per day, as well as what would happen if they were a single price monopoly. In order to derive the single price monopoly, all we're doing is horizontally summing. That is, take this demand schedule, add it to this demand schedule. That gives us this line. And then to the left of the kink, that's just the higher of the two lines. And then you can define the marginal revenue. Similarly, it's just the marginal revenue for this firm before the kink, and it's the marginal revenue for both of them together to the right of the kink. And the question here is, well, run it back. What is the optimal price and quantity in each country, and what happens when you separate? We could do this graphically as before. Marginal cost equals marginal revenue, follow the curves. Or we could do this more carefully. Go through and find the equation for the demand schedule and the marginal revenue in each case using the graph. Then add the demand schedules horizontally to find the equation for this line. And then set R equals MC and prove to yourself that the graphical answers shown here are correct. If you did it right, you would have noticed that inverse demand in country 1 was P1 equals 6 minus Q over 2. If we set marginal revenue equal marginal cost, we would find price equals 3.5 and quantity equals 5. In the other country, inverse demand would suggest price equals 9 minus Q. Setting MR equals MC, we'd find price equals 5, quantity equals 4. And lastly, the horizontally summing, you'll note that if Q1 equals 12 minus 2P, Q2 equals 9 minus P, over the region that they overlap, we'd have 21 minus 3P, again, summing in the quantity direction. And if we set MR equal MC, we'd get price equal to 4. So if we do this correctly by mathing out the equations, we'll get the same answer suggested by our example graphs. So solving for group price discrimination, optimal price and quantity is very simple. You just perform the same exact math we did with monopolist. You just do it separately in each market. And then figuring out what you would have done in a single price monopoly is simple. You just sum horizontally and then do the monopoly math again. So one last exercise. Suppose the demands are given as thus in the two different countries, and do the same exercise. What is price and quantity in each market? Who pays more per unit and why? And then lastly, what is total demand as well as price and quantity if we're doing a single price monopoly and we combine the two markets? Go for it. Let me know how you do. In my math, for group 1, I found that the equilibrium optimal price was 3 halves and we sold 6.5 goods. For group 2, we charged $3 and sold total of 9 units. And in the total market, I set the price equal to 11 thirds and sold 14 goods. Hopefully that's what you got too. So one more thing we should talk about. And when I say talk about, I mean just talk about. We will never have time to go over this, so I always just kind of push it under the rug. So we've talked about perfect price discrimination, where you just charge everyone the reservation price. We've now shown that it's pretty easy to solve for group price discrimination. Just set MR equal to MC in both markets. However, there is one last case, and that's the case where all people pay the same prices. I mean, they pay along the same price schedule. However, the prices you change are based on the quantity. When does this happen? Think of cases where people are charged based on how much they buy. The most obvious examples are places like big box retailers where you can buy a big box or you can buy a small box and they charge different units. Ultimately, it could be places like the hardware store where they have a sliding scale based on how many boards you buy. This is used all the time. People who buy in bulk pay less. Here's a funny example of nonlinear price discrimination that I found on the web years ago. Look at this picture and see if you can tell me why I took this picture and why I think it's funny. Hint, it's nonlinear price discrimination done wrong. Hopefully you noticed that the wireless charger with play kit is a bundle of the two goods on the right, the play kit and the controller. Since it's a bundle, you're forced to get both objects together. We'd think this would be offered at a savings. However, if you were to buy the controller and the charge kit, it would come out to about £70. However, buying them together costs you an extra $5. So somebody who set the prices here was a goofus and they messed it up. But it's funny. The reason it's a mess up is you could just buy both of these together. Anyone buying this could get 2 boxes and save themselves $5, right? There's no cost to them to just have both. So all I ever want you to know about nonlinear price discrimination is it's the same math, right? Imagine we have people who are going to buy goods, either in large amounts or small amounts. We could say, well, we have small amount consumers and large amount consumers, and we can just say that we're going to charge the same marginal revenue to both groups. I mean, with the same, we're going to set marginal revenue and marginal cost for both groups. This devolves into the exact same math for group price discrimination. So although I might, for instance, in a quiz or test problem, ask you to solve nonlinear price discrimination problems, all you have to remember is that you need to set marginal revenue and marginal cost for both sets of the good, i.e. for the small amounts and for the large amounts. That's all we have time for today. Hope you enjoyed it. Catch you next time. Happy end of Block 2. Bye.